The moon always shows us the same face, a familiar sight that has inspired wonder, stories, and scientific curiosity for millennia. Yet, its far side remains forever hidden from Earth's view, a mysterious hemisphere that eluded human eyes for most of history. This phenomenon is due to tidal locking. The moon rotates at the same rate it orbits us, so one hemisphere is always turned away, locked in perpetual secrecy. The so-called dark side isn't truly dark. It experiences both day and night just like the side we see. But its remoteness and inaccessibility have kept it shrouded in mystery, fueling speculation and fascination. The far side is a rugged, heavily cratered landscape starkly different from the near side. It lacks the vast, dark lava plains called Maria that dominate the moon's familiar face. Scientists believe its crust is thicker and much older, preventing volcanic resurfacing and preserving a pristine record of the moon's earliest history, an untouched archive of the solar system's violent youth. The South Pole Aitken Basin, one of the largest and oldest impact craters in the solar system, lies here. This colossal scar may hold rocks from deep within the moon's mantle, offering clues to its internal structure. Studying this region could reveal secrets about the moon's formation, the history of impacts in the early solar system, and even the processes that shaped our own planet. But landing and communicating on the far side is a technical challenge. Because it's shielded from direct radio contact with Earth, missions require relay satellites, advanced technology, and precise navigation to succeed. No mission had ever returned samples from this hidden hemisphere, until now. This achievement marks a new era in lunar exploration. The quest to explore and understand the far side is a leap into the unknown, promising discoveries that could reshape our knowledge of the moon, and perhaps even the origins of life on Earth. The far side's untouched geology is a time capsule, waiting to be unlocked by science and human curiosity. The next chapter in lunar exploration begins here, as we set our sights on the moon's most mysterious frontier. In 2024, China's Chang'e 6 mission made history by becoming the first to land on the moon's far side and successfully collect precious samples. This remarkable achievement pushed the boundaries of space exploration, venturing into a region that had never before been explored by humans or robots. The mission targeted the Apollo Basin, a vast crater within the ancient South Pole Aitken Basin. This area is one of the oldest and deepest impact sites on the moon, making it a scientific treasure trove. By retrieving material from this region, scientists hope to unlock secrets about the moon's early history and the solar system's formation. The robotic lander, equipped with advanced instruments, used a scoop and drill to gather about 2 kilograms of lunar soil and rock. These operations were guided remotely from Earth, with signals relayed through a dedicated satellite orbiting above the moon's far side, overcoming the challenge of direct communication. After the samples were collected, an ascent vehicle launched from the far side surface, a feat never before accomplished. It rendezvoused with the orbiter in lunar orbit, transferring the precious cargo for the long journey back to Earth. The mission's flawless execution was a testament to China's growing expertise in space robotics, mission planning, and lunar exploration. Teams of scientists and engineers worked around the clock, monitoring every step from mission control. In June 2024, after a 53-day journey, the return capsule parachuted safely onto the grasslands of Inner Mongolia. The world watched as recovery teams rushed to secure the capsule, marking the triumphant end of a mission that captured global attention. The samples brought back are fragments of a previously unreachable world, offering scientists a unique opportunity to study the moon's far side. These materials could hold clues that may rewrite our understanding of lunar evolution and the history of our solar system. The success of Chang'e 6 marked a turning point in space exploration, establishing China as a pioneering leader in the new era of lunar discovery and inspiring future generations to reach even further into the unknown. Once the Chang'e 6 samples returned to Earth, scientists eagerly began their analysis, hoping to unlock new secrets about our closest celestial neighbor. What they found was nothing short of extraordinary. Tiny fragments of carbonaceous chondrites, a rare type of meteorite, rich in water and volatile compounds, hidden within the lunar soil. These meteorites are considered some of the oldest materials in the solar system, and their presence on the moon opens a window into ancient cosmic events. This is the first direct evidence that water-bearing asteroids once bombarded the moon, delivering not only water, but also the essential building blocks for life as we know it. It suggests that the moon's surface was shaped by more than just volcanic activity and impacts. It was also a recipient of cosmic ingredients from deep space, The findings confirm that some of this water likely became trapped in the lunar soil, especially in the permanently shadowed regions near the poles, where sunlight never reaches and ice can persist for billions of years. The age of the samples ties this process to the late heavy bombardment, a chaotic era over 3.8 billion years ago, when the inner solar system was pummeled by asteroids and comets, dramatically altering the surfaces of planets and moons alike. This discovery strengthens the case for significant water resources on the moon, which could be vital for future lunar bases and long-term human exploration. Water is not only essential for life, but also for producing fuel and supporting sustainable missions. Water ice can be split into hydrogen and oxygen, for life support, drinking water and rocket fuel, making the moon a potential refueling station for deep space missions and a stepping stone to Mars and beyond. The Chang'e 6 samples could be the key to humanity's future in space, turning the moon into a gateway for exploration and a hub for scientific discovery. The moon's ancient water is not just a scientific prize, it's a resource that could fuel the next era of human spaceflight, opening new frontiers for generations to come. Chang'e 6 is just one step in China's ambitious lunar roadmap. The upcoming Chang'e 7 mission will explore the lunar South Pole, searching for water ice in permanently shadowed craters. Chang'e 8 will test technologies for using local resources, including making bricks from lunar soil, crucial for building a base. China aims to land taikonauts on the moon by 2030, using new rockets and spacecraft designed for crewed missions. The long-term goal, the International Lunar Research Station, a permanent outpost near the South Pole, powered by a small nuclear reactor. China is inviting international partners, positioning the station as a global platform for science and resource use. This methodical, state-driven strategy is building the foundation for a sustained human presence on the moon. The era of taikonauts walking on lunar soil is fast approaching. The world is witnessing a new moon race, China's steady state-led program versus NASA's Artemis, built on international and commercial partnerships. China's approach is methodical, with each mission building on the last, and major milestones achieved on schedule. In contrast, Artemis has faced delays due to shifting priorities, budget uncertainties, and technical hurdles. The Artemis 3 mission, aiming to return Americans to the moon, has slipped to at least 2028. Many analysts now believe China may land taikonauts before NASA's next lunar landing. While Artemis emphasizes collaboration and commercial involvement, China's model is centralized and state-driven. This fundamental difference is shaping not just the timeline, but the very nature of humanity's return to the moon. Unlike the Cold War's sprint to the moon, today's race is a marathon to stay and build. Both China and the US aim to establish permanent lunar bases, focusing on resource extraction, especially water ice at the South Pole. The first to harness these resources will gain a strategic edge, turning the moon into a launch pad for deeper space missions. Two geopolitical blocs are forming: the US-led Artemis Accords Coalition and China's International Lunar Research Station Partnership. The group that establishes a foothold first could set the rules for lunar governance and resource use. This competition is driving rapid innovation in robotics, propulsion, and life support. The outcome will shape the cislunar economy and determine who leads the next era of space exploration. The moon is becoming the gateway to the solar system, and the stakes have never been higher. Beyond competition, lunar exploration is a shared human endeavor, driven by curiosity and the quest for knowledge. Discoveries like those from Chang'e 6 enrich all of humanity, revealing clues about the origins of water, life, and our solar system. Technologies developed for the moon, life support, energy, recycling, can transform life on Earth, addressing challenges like resource scarcity and climate change. Building a sustainable presence on the moon demands global cooperation and long-term thinking. The moon is a testbed for new models of governance, stewardship, and collaboration. Whether it's taikonauts or Artemis astronauts, their next steps will be a victory for all of us. The journey back to the moon is a story of ingenuity, perseverance, and hope. In a divided world, the moon invites us to look up and imagine a future we build together.